first place, I want to express my sincere gratitude to Ivan and Alex for including me in this workshop. I genuinely appreciate both for organizing this event, and it's truly a privilege to have the opportunity to share my thoughts with all of you and to know this beautiful city for the first time, so thank you very much for that. Well, as Alex said, my presentation will be about some reliability criteria for scientific thought experiments. I'm thinking mainly in thought experiments in physics. That's the cases that I've been studying the last years. So in my presentation I will try to propose what I think that the reliability criteria for scientific thought experiments could be. But first of all, I want to say that thought experiments have played an important role in theoretical physics and cosmology since the scientific revolution, influencing the works of Newton and Einstein, for example. And they become an important topic within the philosophy of science, generating a number of philosophical papers exploring their functioning and evidential significance. And this is the context, the literature that is the context of literature that in my work is screening. Despite this extensive analysis, there is no consensus on the criteria to distinguish successful thought experiment from spurious one, and this is the problem that I want to attach in this presentation. So I will introduce a set of criteria to assess the reliability of scientific thought experiments, and I will try to do this in 3 steps. First, I want to explain what do I mean when I say that I will present reliability criteria. I will present in second place my understanding of the functioning of thought experiments, and in third place I will say what are the reliability criteria for scientific thought experiments specifically. So the first point, what do I mean by reliability criteria? I think that when we talk about reliability in the context of thought experiment, we can relate this idea with valid inference rules. That was something that was already said here. When we have deductive arguments, we can talk about valid deductive arguments, and we talk about when we are in front of an inductive argument, we maybe have to say a lot more on this way. I won't deep in this, but Norton, for example, talks about preservation of probability. So one way to think about which could be the reliability criteria for experiment, we can talk about valid inference rules that we can apply to say this is a successful or a not spurious thought experiment. A second idea that we can present to talk about reliability criteria is the ideas that are related with the epistemology of real experiments, as for example Franklin presented, but Hakim also did. These are the strategies that focusing in the practicing of experimenting. Franklin spelled out, and he talks about intervention, replicability, independent confirmation, reproduction of artifacts. I mean, that's the human error that the machines or the instrument produce, the elimination of sources of error, the use of the results themselves to argue about their validity, the employ of correlate independent theory of the phenomena to explain the results, and so on. So these strategies are, as Franklin presented, the ones that are generally used to as good reason to believe in experimental results. So when we talk about reliability criteria for experiment, we can think on these two. We can also appeal to the idea of calibration. That is a process that also took place in natural science. This is the process of adjusting and verifying the accuracy of a measuring instrument, as Franklin also presents in this paper related directly with this idea. Maybe you can think that we can calibrate thought experiment, trying to measure them with real experiments, but this is not exactly the idea that I will to present here. And another way to think on reliability criteria is one idea that was developed by Weinsberg in a paper of 2010. He proposed that the validation of the computer simulation is a process that cannot be separated from other processes as verification, ratification, and comparison with the experimental results. In this conception, the Weinsberg one, to know if a computer simulation is validated, it is necessary to use many resorts, and they use it simultaneously. So the other idea to present reliability criteria is to use simultaneous confluence of the strategies to say if a thought experiment is reliable or not. So in these 4 ideas that I present, I think I will try to go to some of the theses that I present, but I'm mainly thinking that the reliability criteria of thought experiments is related to the last one. We need the simultaneous confluence of different strategies to establish if a thought experiment is or not a good one. So, why I say this, why I said that we need a number of strategies. I say this because I understand that thought experiments are imaginative exercise that draw upon a range of resources, including theories, visual representation, and accumulated empirical knowledge. And this exercise enables us to make inference about the natural world without directly intervening in it. So I'm saying that thought experiments are this kind of exercise and use this range of resources to try to not committing with one ontology of thought experiments, but I think that we look at the cases, we can find that this way of describing what a thought experiment is, this is not a definition, it's more or less suitable for the more important cases at least, or many cases. So when I say that this is what I understand about the functioning of scientific thought experiments, I want to say with this that successful thought experiments are those that can contribute to increase scientific knowledge, expand this knowledge, show inconsistencies, erase new phenomena, for example, new phenomena there is no theory to explain it, or propose new theories. So a successful thought experiment is going to be this kind of imaginative exercise that can contribute in these different ways to increase scientific knowledge. So what I will present is a set of conditions that can be applied to the evaluation of thought experiments. These conditions respond to their nature, that I will say this sui generis. I don't want to give a definition of thought experiment or an ontology of what kind of thing it is. I did this in another places. I talk about thought experiment as models, but I won't commit with that. I think that these conditions could attend this different characteristic of thought experiments. They use different resources and there are imaginative exercise. And we can use this set of conditions to establish the reliability criteria of these many characteristics of thought experiments. I will attend especially in the imaginary scenario, in the empirical knowledge related to the thought experiment, because I'm talking about thought experiments in science, and especially I'm thinking in cases of physical thought experiments. And also I will try to attend the theoretical interpretation of the results of thought experiments, how these different parts of the thought experiment interact. So this is the fourth parts or characteristic of the thought experiment. I will try to propose reliability criteria to each one of these parts. So the first part or characteristic of a thought experiment is the imaginary scenario, as I think that Alex said, but also Ivan said moments ago. Thought experiments including usually the description of some scenario or sometimes counterfactual circumstances. I want to say something about what things can go wrong with this scenario and how we can try to prevent this wrongness or this spurious thought experiment. Sorry. I try to do something else. Okay, when I talk about the imaginary scenario, I want to say that when we read the narrative of a thought experiment, we get with some details, with some description of the scenario to a situation that is a description that develops and gives a result or a devolution of a system, for example, and a result. So I think that in this description, the description of the scenario has to have all the relevant details and variables that will be manipulated in this imaginary experiment, and the description has to attend to their correlations. I mean, the way that one of these variables affects others, and in the case that the thought experiments include an apparatus or an instrument we have to activate in the thought experiment, then this description has to be good enough or complete enough. And also in the description of the thought experiment, all the details that in the real world, for example, exist but are omitted in the thought experiment, it should be clearly present in the description of the scenario. There are some, for example, details that are omitted or some characteristic of the words that are idealized. This is part of the description of the scenario of the thought experiment. So, what I want to say is in what sense a description of the thought experiment is satisfactory and how comprehensive the narrative should be, how detailed it should be. So, we can find that some thought experiments fail because the description of the imaginary scenario is incomplete or imprecise, so I can't make a difference between these two characteristics. An incomplete description does not take into account the relevant initial conditions, so if in the narrative we don't find all the descriptions or all the initial conditions are properly described, probably that thought experiment won't work well. And a description is imprecise when this ambiguous or obscure, but is not failing in considering all the variables that are involved. So a successful thought experiment must satisfy this condition, that is to clearly present the experimental setting or apparatus from which it is proposed to test a hypothesis. In the cases when the thought experiments are intended to be crucial experiments, so the description of the scenario must be done in terms that the supporters of two rival theories will accept it. This suggestion is not original, but I think it's very important. Popper already did that in the logic, but I think that it's important to remember that if you caricaturize a scenario, that could be a not acceptable version of what's going on for somebody that you are debating to. So I think that to assure that the description of a scenario in a thought experiment is good enough, we have to try to present it in a very specific way, where all the characteristics of the setting and the apparatus or the instrument relevant are descriptive in a precise way. And we have also tried to avoid, I forgot, what is usually called weirdness. I mean, these scenarios that are too far-fetched to our common knowledge, or at least the empirical knowledge at the moment, because it's not, we cannot be sure that in that kind of scenarios we can exhaustively describe all the characteristics and all the correlations that is important to connect. The second aspect of flow experiment that I want to put my attention is the role of the experimenter. As James Brown said many times, flow experiments are performed in the laboratory of mind. So the experimenter is who is running the flow experiment, not the one who is writing the flow experiment or proposing the flow experiment, who is reading the flow experiment and trying to follow the instruction and perform the flow experiment in his mind. So the experimenter is who is running the flow experiment, and in this special case, the flow experiment depends on the competence of the experimenter. So a flow experiment could have a complete description of the initial condition, the instrument, and so on. But if the experimenter is not able to infer conclusions because he don't have the, for example, the nomological framework to conclude what will happen in this context with this hypothesis, so the flow experiment will fail. Or if the flow experimenter is unable to apply the correct concepts, the flow experiment fails, even though the description of the flow experiment is correct. So these are cases why the flow experiment can fail that are dependent on the experimenter competence. There is another way to present this idea. It is that somebody can have wrong intuitions that are triggered by the flow experiments. I found all the literature about intuitions in physics, especially a little obscure. There is like a general idea of what intuition means in physics paper, and this is something that is empirically investigated. And when physicists talk about intuitions, they usually talk about this way of thinking that involves visualization and the ability to have some accurate ideas of the physical knowledge. But there is not the notion, the philosophical notion of intuition that we are used to debate. So I think that we can left aside the language of intuitions when we talk about the experimenter's ability or competence to perform a flow experiment, and we can say that a flow experiment will be a successful one if the experimenter who performed the flow experiment share a set of beliefs which the creator or the writer of the experiment have, and have the competencies and the abilities and the background knowledge enough to perform the flow experiment. I mean, it can follow the analysis that is proposed in the narrative to infer some conclusions from there. We can say this in the language of intuition, saying something like we have like the correct intuitions because we have been educated to have that intuitions, but we can avoid that and just say that that what we need to a flow experiment in physics, for example, is successful is that the experimenter share this background knowledge and inferential abilities. Well, I will attend to another condition that is important to make a reliable flow experiment. There is what concerns to the theoretical interpretation. I have talked about the description of the scenario. I said that what is needed to the experimenter to perform correctly a flow experiment. We at least it's possible to separate in a flow experiment the theoretical interpretation and the material realization, following this famous radar distinction. And we can say that at least in the preparation of interaction phases, that are the similar phases that in real experiment, we could describe the flow experiment in a theoretical neutral language, but the interpretation of the result of a flow experiment is embedded in a theoretical frame. So when we talk about theoretical interpretation in flow experiment, and if we accept this idea that we can separate the description of the scenario and the theoretical interpretation of the result, we can have some situations that are sometimes problematic in the flow experiments, and I want to try to avoid with this criteria. One is that with the same initial conditions, we can have different interpretations about how in a flow experiment physical system will evolve. We can have different interpretations about what will happen in these initial conditions, or we can have the same description of how these imagined physical systems evolved, and different theories that interpret the results. So we can have the same flow experiment, which I mean is like at least in the this neutral language description of what will happen in the evolution of this system, how that will develop. We have like agree in that, but the result could be taken as evidence favorable to different rival theories. For example, the tower flow experiment that Galilean and Aristotelic interpretation is the same experiment. What will happen if you throw some object from the top of a tower, but the result, that it will fall to the foot of the tower, is opposite for both theories. And this is because you can derive different morals from the same flow experiment. So to avoid this ambiguity, I think that what is needed to have or to attend to a correct theoretical interpretation of a flow experiment is specify the relevant assumption in the case. I mean, if you have two rival theories, you have to be very clear what the two rival theories accept, and we can check the interpretation of the result, reconstructing the argument that follows. Well, this result is a proof of that, for example, for the Aristotelic, the Earth is not moving, or for the Galilean that works like an inertial frame. So what we need to check that there is a good argument, a good interpretation of that phenomena could be have a reconstruction, an argumental reconstruction. I think that this reconstruction could be made by some of these models that were present, for example, Hack's model or Sorensen model, but I think that also other kind of inference, for example, inference to the best explanation, could be reconstructed. I think not all flow experiments are arguments of some kind of modus tollens argument. I think there are ampliatory inferences, and it could be like reconstructed in a at least acceptable way. And I have proposed this idea of how to reconstruct these flow experiments that are inference to the best explanation in a paper of 2017 that I worked with my friend Bruno Borge. Okay, so the element of the theoretical interpretation, what I want to remark here is that to be sure that there is a good interpretation of the result of the experiment, we have to attend what kind of argument is going on. And finally, I think that we can attend to the result itself of the experiment, the outcome of the experiment, and we can use some of the strategies used in the epistemology of real experiment to believe in that results. So the result of a full experiment could be compared with the result of real experiments or scientific models of some kind, for example, computer simulations, other results, for example, of the observation. We can compare what observation, experiments, and computer simulations said about that kind of phenomena. In the thought experiment, it's reliable to evoke to well-known phenomena. I mean, to not go too far in this phenomena that are evoked in the description of the experiment. We can use the description of widely used experimental apparatus, for example, such as Geiger counters. We can use a criteria for this part of the experiment for evaluate the results. The idea that the results that is followed from a flow experiment is a yes or no answer for the question that motivates the experiment. If the result of the experiment doesn't give us a concrete answer to the question that motivates the experiments, maybe it's not a good flow experiment, or we can trust in that imaginary exercise to think in that physical problem in particular. So, to recall what I said, I think that we can use a number of strategies that are taken from the philosophy of experiments and also from the philosophy of computer simulations and also from the logic applied to the exam of flow experiments. And these are the criteria that I have proposed to scientific flow experiments. I think that a reliable flow experiment provides a satisfactory answer to the question that motivates the formulation of the flow experiment. I think that to the flow experiment works properly, the experimenter has to share a set of belief, competence and abilities, and also background knowledge with the the proposer of the experiment has in mind. For a reliable flow experiment, it's necessary to specify the relevant assumptions that are behind the description of the scenario, and that assumption in the case there are two rival theories that interpret, that are trying to explain the same phenomena. This description has to be made in a theoretical, neutral language that is acceptable for the two rival theories that are trying to explain the phenomena. We can assure that a reliable flow experiment is such because it involves a valid argument for deductive arguments, but we can reconstruct also inductive arguments, as I said a moment ago. To assure that a flow experiment is reliable, we can evoke well-known phenomena and use in the description of flow experiment widely experimental apparatus used in real experiments, so we can rely on flow experiments that evoke this kind of phenomena or use in the description this kind of experimental apparatus. Well, I repeat the same thing twice. So, to conclude, I think that all these criteria about what is a successful flow experiment in science, especially in physics should be used together to evaluate thought experiment. I'm not saying what a thought experiment is, but I think that describe thought experiments as an exercise that involves imagination and scientific theories and empirical knowledge will demand that a good thought experiment depends on all these criteria, the ones that are involved with the description of the scenario, the ones that are involved with the theoretical interpretation of the thought experiments, about the inference that we make to interpret that result, and so on. So, assessing the reliability of thought experiments should be done case by case basis. I think we cannot give a unique criteria for all thought experiments, because we have to place the thought experiment in question in context and clarifying the underlying assumption as far as possible. We have to put in a context, I mean, there are a lot of thought experiments that have been discussed in the literature of thought experiments. We need to clarify the assumption that in some historical context we are the one that we are sustained for that case. Otherwise, we are maybe not using the same thought experiment if we took off from this original context. And maybe out of its original context, the thought experiment is not as good as was in its original version. I think, finally, that these criteria are not necessarily equivalent to rules to building good thought experiments, especially in science, but we can use it as suggestion for doing that, to construct good thought experiments. Well, that's all. Thank you very much.